Hey everybody, it's Jenny from Wright and NSW PEP. In the last video, I talked about direct-to-chip cooling, so let's cover the last type of liquid cooling this week, immersion cooling. Let's get started. So what is immersion liquid cooling? Like the name implies, in immersion cooling, the server and other components in the rack are submerged in a thermally conductive dielectric fluid. The dielectric fluid is either hydrocarbon or fluorocarbon. There's no need for air cooling because immersion cooling maximizes the thermal transfer properties of liquid and is the most energy efficient form of liquid cooling. So let's move this over and look at it. If we bring up the system image from the last video, the components on the left are still the same. But let's erase this side of the image, and instead of a plate that is in contact with the chip, like in direct-to-chip cooling, the whole server is submerged in a coolant tank like this. So this is the tank with the servers inside, and let's connect the piping to the tank. So just like with the rear door heat exchanger or direct-to-chip system, there's a chilled water loop that goes to the cooling distribution unit, and then the CDU controls the coolant loop to the immersion tank. Let's move this over again. So there are also two methods of heat transfer in immersion cooling, single phase and two phase. In single phase cooling, heat is absorbed by the coolant and the fluid remains in a liquid state throughout the process. In two phase cooling, the servers are sealed into a tank. The liquid has a low boiling point and the heat turns the liquid into gas, causing a phase change. This gas goes through a water-cooled condenser coil placed on top of the sealed racks. Inside, the vapor is transformed back into liquid, which drips back into the tank and is recycled through the system again. Now let's slide this over again. So what are the benefits of immersion cooling? Immersion liquid cooling decreases the total cost of ownership and can improve the IT hardware lifespan. It also allows for a homogeneous temperature throughout the components so they're not stressed by sudden temperature changes. But there are some challenges to immersion cooling. There isn't a dedicated standard on what type of fluid to use. The fluids used in immersion cooling need to be inert, do not degrade the insulation, or remove the glue holding the labels on the equipment and the cables, and it can't react with inks on the motherboard, chips, or other components. Fluid management is another consideration. What if the fluid leaks, and how do you dispose of it? And then there's maintenance and accessibility. How do you do maintenance on submerged servers? Will you need an overhead crane system to work on the servers? So let's bring all this back on screen. So that's an overview of immersion cooling and how it works and some things to consider when doing immersion cooling. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next time.